This is Mrs. O'Neill for AP Chemistry, Chapter 7, Section 3, Sizes of Atoms and Ions. In this section, hopefully you'll understand the relative sizes of atoms and ions and the trends that are on the PT. So again, I suggest to pause, fill in the blanks, and then play to hear my words. So this atomic size, how in the heck do they get this atomic size? Well, there's two ways, called non-bonding radius and bonding radius. So the non-bonding radius and the bonding radius, the easiest way to show you what happens here is this. So when you have a bonding radius, that means one atom is bonded to another. Think of your diatomics. So let's say that this is bromine, Br2. So the distance between one nucleus and the other, they would take that full distance and cut it in half. And then that would be the radius of one Br atom. That's the most accurate way. I believe that they found the radius of these atoms. The non-bonding radius would be, again, just take that atom, get the nucleus, go to the outside where those electrons are. And that outside level, or that outside area where the electrons end, that's really a fuzzy area. And that's why I say that's not as accurate as if you take two atoms that are exactly the same, you get the distance between the nuclei to the nuclei, and then split it in half, and that's your radius. That's the more accurate way, because you really don't know where that electron cloud ends. So what are the trends in atomic radii? Well, going down, since you increase in energy levels, your electrons are going to be further away from the nucleus, so the size of those atoms increase. Going across, however, does the opposite. The radius or the size of those atoms decrease. Now, why? Well, hopefully you understand now the nuclear charge from section 7.2 and understand that the more protons you have and the more electrons you have, the more attracted they're going to be together. So if you have 3 against 3 versus 5 against 5, you have more, I want to say, attraction between those 5 electrons and 5 protons in the nucleus to draw on each other. And that's why it gets closer or smaller. So here we go. Here's the atoms. So again, as we go down, the size of the atoms increase because in period 1 you have 1 energy level, in period 2 you have 2 energy levels, in period 3 you have 3, and so on. Now going across, again, look at the size. The size is getting smaller. Why? Because you have less proton-electron attraction here versus all the way over here on those nonmetals. You have more protons and more electrons attracted to each other. So the attraction is going to bring them in. And here's just another visual to get you to understand the atomic radius and the trends. How about ionic radii? Now this is pretty easy. Cations are smaller than their atoms. Why? They're losing electrons. If you lose electrons, especially most of your cations, most of your metals are going to lose that whole outside energy level. So of course then your ion is going to be smaller. Versus anions are larger than their atoms that they come from because again, you're gaining electrons. If you're gaining electrons, then you're going to have more negative than positive. So you're going to have that attraction is going to be less, and if that attraction is going to be less between the protons and electrons, you're going to have a bigger atom. So again, down the group, ions carry the same charge, ionic radius increases. So here, again, you might want to pause and kind of look at this and make sure that you understand the difference between your cations, getting less in the ion, or I should say, yes, your ions are smaller than the atom it comes from, and then look at your nonmetals and how your ions are going to be larger than the atoms it comes from. Isoelectric series, that just means that you have an ion or a group of ions that have the same number of electrons. So if we look here, all of these ions, F-1, Al plus 3, Na plus, O negative 2, Mg plus 2, they're all going to have the same number of electrons. So they're called isoelectric series. So if we go from the element of fluorine, which has 9 electrons, go to its ion, now it has 10. Aluminum started with 13. When it became an ion, now it has 10. Sodium, 10. Oxygen, 10. Magnesium, 10. Okay, so this is where it gets a little crazy or a little difficult to know which atom or ion is bigger than the other when they have the same number of electrons. And this is where you have to then look at, remember, in a neutral atom, the number of electrons equals the number of protons. So then you have to go by that attraction between those protons and electrons to figure out who would have the smaller radius and who would have the bigger radius. And again, going back to, I'm going to go back to this, again, it goes back to that nuclear charge. So we want to keep that in mind. Okay. Okay, see you in class.